Good evening. In previous session, we have seen the concept of inheritance and types of inheritance we have seen. So in that types of inheritance, we have to see in detail about hybrid inheritance. So just briefly, I will explain about what are the different types of inheritances we have seen in previous session. So first one is simple inheritance, or we can say it as a single inheritance. Okay, here one class is going to acquire the properties of other class. So here B class is acquiring the properties of A class. Next, if you are going to consider multiple inheritance, so multiple, here more than one parent class will be there. From all these classes, one class is acquiring the properties. Okay, so this is called as what? Multiple inheritance. One class is acquiring the properties of many parent classes. Next, multi-level. That means in the name it says what? Multiple levels are there. For example, A, B, C are there. Here, B is acquiring the properties of A and C is acquiring the properties of B, and so on. Next, let us see about one more thing, that is hierarchical. Okay, hierarchical. In this, one parent class will be there and multiple child classes will be there for that parent. This is called as hierarchical. Next is cyclic. Cyclic inheritance is nothing but what? Same class, that is what? A is acquiring properties from A. Is it possible? It is not possible. In the same way, B is acquiring properties of A and A is acquiring properties of B. It is also not possible. Where it is going to form what? Cycle. It is what? Cycle. Here what? A itself is going to get its own properties, which is not possible. So cyclic inheritance is not possible in our Python. Not only in Python, in Java also it is not possible. Now, a last type, that is what? Hybrid inheritance. What is that? Hybrid inheritance. So in the name it says what? Hybrid. Hybrid is what? Mixing of more than two. Okay, or we can say more than one. For example, A is there, here B, C, and let us consider here D, E is there, here G, H, next one I, J, K. Let us consider. Okay, so this is what? This is a hybrid inheritance. So here what can I say here? It is hierarchical. Here next what we can say? Let us take this one also. It is what? Multiple inheritance. So in the same way, this is what? Multi-level inheritance. So the combination of any inheritance, the combination of any inheritances is called as hybrid inheritance. So already we have seen about examples of all these single, multiple, multi-level, hierarchical and cyclic. Now in today's session, we are going to discuss about hybrid inheritance in detail. So before going to see hybrid inheritance, let us see one small example how the method resolution takes place. What is meant by method resolution means I will explain now. So class A I am going to take. In this I am going to take one method, define M1. So in this just I will print only one statement, print of, for example, method 1. Okay, right, only one method I am going to take in class A. Now I am going to take class B, which is going to inherit the properties of class A. So in this I will not take any method, just I will pass it. So already you know what is meant by pass. Pass indicates what? It is not having, the class is not having anything. It may be methods or it may be data. Next, I want to create an object of type B. So let us take the name of object is B, small b. So B space capital B. Now observe here, I am creating object of type B. Now if I call B dot M1, observe carefully here. So whenever I am calling B dot M1, B is which type of object? B is class B type of object. Otherwise, not to make confused, I will take it as an X. So X is which type of object? B type of object. So if I am going to call X dot M1, so first it will search in which class? X is which type? B type. So it will go to B class. Is there any M1 here? So it is not there. So that it will go to its superclass. That means what? What is the superclass of B here? A. So it will go to A and it will search for M1. Is there any M1? Yes. So method 1 will be executed. Or just I will write here class A. Class A method 1. Class A method 1 is going to execute. Just let us see the output of this program. So see what we got here, class A method 1. Now just I will change the scenario here. Here I will write method 1. Here I will copy and paste the same method. Here I am going to write what? Class B method 1. Okay. Now observe here. Okay, anyway, I will leave it as it is. So now what happened? Here in B we are having and A also we are having. So just I will execute. What we are going to get? We are going to get class B method 1. The meaning is what? First your Python interpreter will check for exact match. That is not exact match in that particular class only. X equal to B. This X is which object? B class object. So when I am calling X dot M1, first it will go to B class because X belongs to what? B class. So it will go to B class and it will search for what? M1. Is there any M1 here? Yes. So it will execute that particular method. If it is not there, then only it will go to class A. Okay. This is very important point to understand. So first the same, it will go to the corresponding class. If it is not there, then it will go to its super class. Now I'm going to consider one more class here. Let us go to multiple inheritance now. So class C I am going to take, and here I am going to extend the properties of B. Here I will take the same method 1. Here I will take what? Class C method 1. So now I want to create the object of type C. Now see, X is which type of object? C type of object. Now let us consider. I will not take this one. Just I will write pass here. Okay. In the same way here also, first I will take pass. Okay. Now see, here X is which object? C object. So X dot M1 means first it will go to where? C class. In C class, is there any M1? Not there. So it will go to the super class of C. What is the super class of C? B. So it will go to B class. Is there any M1 in our B? Not there. So what is the super class of B here? A. So it will go to super class of A. So is there any M1 in that? Yes, it is there. So it will be printed. So now what will be the answer of this program? Class A method 1. Okay. Next, just I will change the second statement. Sorry. In class B, I will write method 1. Just I will indicate what here? Class B. Now observe here. What happens here? First it will go to C. It is M1 is not present. So it will go to superclass of C. What is that? B. So here what happens? It will go to B class. Already M1 is present. So class B method 1 will be printed. Now observe. So class B method 1 is printed. Now I will write in class C also. So it is what? Which method? Class C method 1. Now calling object is which object is calling M1? X object. X is which type of object? C type. Okay, class C. So X is referring to what? C object, C class object. So that X dot M1 means first it will go to where? C class. Is there any M1? Yes, it is there. So that will be executed. Okay. So class C method 1 is executed. So in this way, it is going to execute. Now, just I will change the concept as multiple inheritance. So C is going to extend the properties of A and B. Observe carefully here. C is extending properties of A and B. Now here X dot M1, is there any M1 in X? Yes, it is there. So here, okay, it is very important point. Now we are talking about this one only. That is what? Method resolution order. This is the why I have executed this particular statement means. Now next concept is what? Method resolution order. For that only I am going to, I have written this particular statement. Okay, right. Now see. Now it is giving you what? Class C method 1. That means what? Before I told what C is subclass of A and B, but also I told you what B is subclass of A, so that we got some exception there. So now I have removed that one so that we are not getting any exception. So X is of C type, so that it executed M1 in C. There is no problem. Now just I will remove this M1 here. Just I will write pass. Okay, now tell me which method is going to execute. As A is written first, so A class M1 has to execute. Now let us check. So A method 1 is executed. Now if in A it is not there, if A it is not there, now let us execute. What happens now? In A it is not there, so automatically it will execute from where? B. So because C is acquiring the properties of A and B, so in A it is not there, so it will go to B, and from B it is going to execute. Let us consider in B also it is not there. Now see, first X dot M1, X belongs to what? C class. So it will go to class C. Is there any M1? Not there. So it will go to where? A. Is there any M1 in A? Not there. Next it will go to where? B class. Is there any M1 in class B? Not there. So what happens? Next, one more super class is there for all the classes in Python. That is object class. As we have seen in our, as we know in Python, in the same way, superclass of all the classes in our Java is what? Object class. In the same way, here also superclass is what? Object class only. Okay, superclass of all the classes is what? Object. All the classes means what? See here. Just I am going to write class A. Okay. Next I am going to write class B. Here I am write class A. So in this case, what is the superclass here? A is superclass. The B is subclass. By seeing this, I can understand. But what about this A? There is only one class A. Can I say which one is superclass and which one is subclass? You may think that there is no superclass for this A, but internally there is superclass for every class. For this A is there. For A, nothing is written here. But by default, object is superclass. So in this case, what happens? It will check in object class also. Is there any M1? Is there any M1? M1 is what? Our own defined method. So will there be any our own defined methods in your object? It will not be there. So what happens? Whatever the method I am going to search for is not available. So it's going to tell you what clearly. C object has no attribute M1. So what happens? See, first from B, first in C it will search. Next in B, so not in B, according to this, it will search in where? In A. After that in B. So first, second, third. Okay, this is the order. Okay, so now after that, after this, where it will search in fourth one, that is nothing but object. Okay, let us see. Sir, whatever you are saying, is it correct? Yes, you may have that doubt. Let us, I want to clarify you by showing the output, whatever I have said is correct or not. Just I will write what? Just I don't want to write anything. Just I will write print of C class. C dot, we are having a method called as MRO. Method name is what? MRO. Don't worry about that method. I will explain. MRO is nothing but method resolution order. So what it is going to you, let us see here. So first one, what it has given? C. Okay. So C, yes. First I have to search in C. After that, in A, I have to search in where? A. Already we know that. Next is what? B. Last is what? Object. Already I have discussed about this object. Okay. So how this is going to be done? As it is a single level inheritance, it is very easy. The not single level means what? Only here what we can see, it is a multi-level inheritance. So I can understand whatever the class I have written first, it will go to that particular class. After that, if it is not available in this class, it will go to second class. It is very easy to understand. But when we go to the concept of hierarchical inheritance, okay, there we are having many levels of inheritance. That is what? First I will take A here, here B I will take, here C, here D for example. This is what? This is hierarchical. Now what I will do? Let us take E here. Let us take F here. This is what? This is the concept of multiple inheritance. Sorry. This is what multiple inheritance. This is what multiple inheritance. Next, I will take here some G. Here we can consider what? A, C, E, F or A, B, E, F. This is what? Multi-level inheritance. So in the same, if you are having many levels of inheritance, then it is difficult to say which one it has to check first. But see here, let us consider here M1 is there. Otherwise, leave here. Come to here. Here M1 is there. Here M1 is there. Now I want to talk about G. So I have created object of type G here, X equal to G. Now X dot M1. Now we have to understand which M1 has to be executed, either from B or from C, or here I will write M1 also, or from D. Okay, so this one we have to understand. Further, we are having a huge explanation is needed further to understand how the method resolution is going to take care in our Python. It is very important because generally this concept will not be discussed. Okay, so we have to listen, you have to listen this concept very clearly and compulsory we have to understand. So I will explain nearly 3 to 4 examples to make you understand about the concept of this method resolution order. Okay, right. So I am going to start the concept of method resolution. 1 minute. Okay, what is that? Method resolution order. Very important. Why we are going to see this one? Because of, if you are having only one level of inheritance, it may be multiple inheritance or multi-level or hierarchical, it is no problem. Directly by seeing that we can understand which method is going to be executed when we call that particular method. But if you're talking about a hybrid, if there are many levels of inheritance, then which one will be executed? That one we have to understand clearly. For that we are coming for what? The concept of method resolution order. Okay, right. So before going to this, what we have to understand? Before going to this, you have to understand two points. Those are superclass is what? Superclass for all the classes is what? Object. Superclass is what? Object. Next point, what we have to understand? First, our interpreter will check what? Child class. If it is child class, the particular method is not present, then it will go to superclass, or we can get parent class. Let us know this is A, this is B, this is C. Okay. Here what happens? B is superclass of C, A is superclass of B. I want to check for M1 some method. So first it will check in C. If it is not there, it will go to B. If it is not there, it will go to A. Next. Okay. Next scenario. Here A is there, here B, and here C I am going to consider. Okay. Here B and C are going to acquire the properties from A. That means first what happens? If I'm going to create object of B, first it will search in B. If it is not there, it will go to A. If I'm going to create the object of C, first it will search in C. If it is not present, it will go to its parent class, that is A. Now A is there, B is there, C is there, for example. So there is only one child class is there, that is D. In this scenario, what happens? First it will, if I'm going to create the object of type D, so D is extending A comma B comma C. So this is class D. Now tell me, here D is first. If I'm going to create object of type D here, if I call some method, so first where we have to check? First in D. After, based on this sequence, I have to check first in A, next in B, next in C. If I write BAC, if I write B comma A comma C, then first here, second here, third here. If I change the order like CBA, then what happens? In C, it will check first. After that in in B, after that in A, according to this one. Okay. By seeing this, we can understand if it is a simple, but if it is not simple, then we have to go for one algorithm. So what I am telling till now, that is about method resolution order. Okay. Now So this is the second point we have to understand. If it is not there in child, then only it will go to parent. Then only it will go to parent. If not in child, if not in child, it will go to parent. Now the concept is, so to understand which method has to be executed when we are having the multiple levels of inheritance, for that we are going for, so the concept is what here? Method, 1 minute. Concept is what? Method, okay. Method resolution. That means what? Resolution is nothing but which method has to be executed. Order. So in some places you can see it as a MRO. Generally we have to call it as method resolution order. Simply they will call in some websites or in some places, in some textbooks also, they will write in a shortcut called as MRO. So here, how our Python is going to how it is going to check the order, based on what it is going to take the decision. So our Python is going to follow one algorithm called as C3 algorithm. Very important algorithm. So I will explain in detail about this algorithm, how it is going to execute. Okay. So in some places we also called it as a C3 linear algorithm. Okay. We can call it C3 linearization algorithm also we can call it. But generally we will call it as a C3 algorithm. Okay. So C3 algorithm, or we can also call it as what? Linearization. Okay. Right. Or we can also call it what? C3 linearization algorithm. Okay. Right. Now, before going to see the algorithm, just I will give you some points. Because already we have discussed, but we have to note these points. That is what? If Python required any method, first way it will search. First it will check, or it will give priority to what? First it will give priority to child class, as we have seen till now. Okay. After that, if child class doesn't contain, if child class doesn't or does not have, then it will go to, or then it will go to parent class, or parent class method will be executed. Anything we can take, it will go to parent class, or parent class method execution will be taken place. Right. If multiple, okay, here if there is only one parent, it is possible. Next, if multiple parents are there, if multiple parents are available, then what happens? Then Python will consider left to right. Already we have seen left to right of declaration, left to right of declaration. Okay. Right. Next, one more point we have to understand. So while checking, once let us take one small example here. A is there, B is there, and C is there. Okay, here three classes are there. Right. Now I want to search for a method, some method. First it will check in where C, next it will check in where A, next it will, let us consider C of A comma B I have written. So from where it has to search? From this side. If it is not present in child class, then it will go to A, then it will go to B. Now once again, will it check in C class after completing all the searching? No. Once, if it is completed all the searching, will it go to A? No. Will it go to B? No. Once all searching is completed, it is not present in C, it is not present in A. Again, will it come to C? No, it will go to B. Once we are searched in C, it is searched in A, it is searched in B. So that method is not present. We will not come back to any other classes. Okay, that means what I can say here, Python will visit any class only once. This is very important point. Okay, right. Now these are the point we have to understand before going to next. Right. So first one is what? It will give priority to the child. If it is not present in the child, then we have to go for the parent class. If for a child multiple parents are there, then we are going to consider from left to right. Okay, and every time what we are going to do, the one class is going to be visited only once. This is about normal scenarios, but now we are going to consider multiple inheritances if it is present. Multiple level of inheritances. Then what we have to do? Then we are following the algorithm called as C3 algorithm or linearization algorithm. Okay, right. Just I will place heading as C3 algorithm. Okay, right. Generally, you will call it as linearization. Okay, right. So first, before going to see this linearization, just I will take few examples, and I will tell you generally what may be the order of our diagram. Just I will take a diagram here. So just I will take here A, here I will take B. 1 minute. Otherwise, what is the superclass of all the classes? Object. From object, I will take object is there, some X, some Y, some Z. Okay. Next, for the Z, X, we are having A and B. Here C we are having. Okay. Next, one more class I will take D. Okay. This is the scenario. By seeing that, this can I tell first in which class it is going to check? For example, I am going to take object of type X, sorry, D. First it will search in D, so I can understand. Next, first it will search in D. After that, the superclass of D is what? A and C. For example, I have written D, A, comma, C, for example. So first it will go to A, next it will go to C, for example. Next, if it is not present in A, then where it has to go? Whether it has to go to C or whether it has to go to X. That is the concept we have to understand now. Okay, so this scenario, I think you got a clarity on this one. Once again, I'm repeating. If it is not in D, it will go to A. There is no problem according to already we have seen. So as I have written in this way, first it will check in A, after it will check in C. But before going to C, will it go to class X or will it go to directly C? Okay, that concept we have to understand. So by seeing the concept of linearization or C3 algorithm, you will get a clear clarity on this one. Okay, right. So before going to the algorithm, just I will say the formula how we have to consider this C3 algorithm or linearization. So that is some L of, I am going to take some X. L of X I am going to take. That means what I want to find the order of searching or order. I am taking some class called as X here. Here if I take A, B, D, E, F. Okay, and here let us take some K. Now I want to create an object of type F here. Okay, now if I want to search some method X dot M1, where it is going to search? First it will search in F, next K, maybe I don't know, next D, next A. How? What is the order? How we can say this order? So for that I am taking some class X here. So L of X, here what I have to take? First, that first class is what? Same class it is going to search, because what here, if I'm taking F object, it will search in F class only. After that it will take merge of, that means what? Combining, merge of L of which class? Some X class I will take, some R Y class. L of Y comma L of Z, or better to take 1 minute parent classes. As these are parent class, I will take L of P1 comma L of P2 comma so on, comma. This is very important point to understand. Whatever the linearization we have taken for this one, all those things here we have to write. Okay, that means what? L of P1 I have written, just you have to write that class name. L of P2 we have written, we have to write that class name here. So this is the first point we have to understand. So don't worry how we have written this one, just I will explain in detail about each and every small point also here. Okay, so here what we have to understand, so x plus merge of L of P1 comma L of P2 and all other linearizations up to here. After that, for whom whatever the classes we have done linearization, write them aside here. Okay, no need of comma here, we have to combine those things and we have to write P1 P2 P3 and so on. Okay, right. Now just I will take a small example and I will show you here. I think you have seen here. So see what is the answer, how it is generated by taking this example, small example. I will tell you. Okay, same. So just for this I will draw a small diagram. This is what A, B, C are there. Okay, so superclass is what? For all the classes object. So for first class I will take object, next A class is there, B class is there. Okay, after that C is subclass, C is subclass, C is acquiring the properties of A and B. So in this way we are having diagram. Okay, right. Now I don't want to show you the answer, but how this is going to be evaluated I will explain. So I want to talk about this C class. So L of C. So first what I have to take, if I want to start this searching from here, first I have to search this one, next this one, next this one. How can I say next this one? Because I have written what? First A only. Okay, so first C I have to write. After that, merge of L of P1. P1 is not what? First parent class. L of C here. What I have to write? Sorry, L of A I have to write. This is next second parent class. That is what? B. L of B. Next comma. Is there any super classes? Not there. Next I can write what? A, B I have to write. So this is in this way I have to consider. Okay. Right. Now how to evaluate? How to get the order now from this? What is meant by this L of A? What is meant by this L of B? I will tell you now. So L of A is nothing but L of A is nothing but. So what is the superclass of this one? Only object is there. So first L of A is nothing but, that means I am talking about A. A should be considered. After that only object class will be considered. Object. Next, if I consider this one L of B, so in which order I am going to take? You can write L of A, L of B, or MRO of A, MRO of B. Order. Just I want to linearization, or we can consider it as a resolution order. No problem. So B, first I have to check if a B object is there. For example, some x equal to B is there. If I write x dot m1, first it will search in where? In x of x is which type of object? B object. So first it will search in B, then only it will go to superclass. That is nothing but object. Okay. So now here what I will write? C plus merge of A space object. So just I will write O here. Instead of object, I will write O. Next, B, L of B is what? B object, comma AB. Okay, right. Now listen carefully. From here, we have to understand. I think up to here it is clear for you. So just I will clear the whatever the unnecessary points, unnecessary diagrams are there, I will remove here. Right. Now, okay. Now observe here. Now, after this, what I have to do? So just I will tell you one statement which is very important to understand. So just I will write here, very important point. So based on this one only we are going to write, sorry, we are going to proceed for this C3 algorithm or linearization. Okay, that is if head element, I will tell you what is meant by head element also. If head element of first list, if head element of first list not present, if head element of first list is not present in the tail part of any other list. Okay, any other list, then we will consider that. Then we will consider that element. We will consider that element in the result. In the result. This is the point we have to understand clearly. Okay. After considering this, whatever the element we have considered, remove that element. After this, what we have to do? Remove that element from all the lists. Remove that element from all the lists. So I will make you clear. Just I will keep this point aside and I will explain many examples here so that you will get a clarity on this one. Right. What is the state? What is just now? I have discussed what about this algorithm. Just I want to tell you. I want to explain about this point now. That point is what is meant by head. What is meant by tail. I will explain now. Just I will remove this one now. As we understood this one, just I will remove. Right. Now see here what is meant by head and what is meant by tail means. For example, A, B, C, D is there. Next E, F, G, H is there. K, L, M, N is there. Okay. Now this first element is considered as what? Head. This is head. This is head. From these three lists, these are heads. Remaining all will be considered as tail. Now if I'm talking about A, I'm talking about A. A is what? Head. Is this head is present in any of the tail part in any lists? Is A is present in here? No. Is A is present here? No. If A is present, for example, A, C, D, F, for example. If A is present here, is it present here? Yes, in this list it is present. But is it present in tail part or head part? It is present in head part only. What is our point? If head element of first list is not present in tail part, it is not present in tail part. So what we have to do? Because it is present in head part only. Okay, in tail part of any other list, then we will consider that element in the result. So which element has to be considered? This A has to be considered as result and remove the element from all lists. So this element will be removed and this element will be removed. Okay. If it is in tail part, I will tell you now. If it is in tail part, that means, right now see, some C, A, D, E is there. Now this is head. I want to search for this one, whether it is present in any other list in tail part or not. So here no A, no A. Here A is there. Is it in a tail part? Yes, it is in tail part. So we should not consider this one. We have to go to next element. Okay, we have to go to which element? I will not search for this one now. Okay, I will go to next list. Not only this, we will go to where? Next list. So this one I will tell you once we will go to see in depth. Okay, once we will go to in depth, you can understand clearly about this one. Right. Now see, I will take one example. So same example I'll continue. Sorry. Right. Just I will remove this one. Right. So when we go in depth, I will discuss about if it is not present, what should be done. Because you may forget all the points if I discuss all at a time. So one at a time I will discuss. Now see, here head is what? A. Head is what? A. So A is present. See, if head element of the first list is not present in the tail part, is A is present in any of the tail parts? No, here it is not present, so no need of checking for A. Here is it present? Yes, it is present. But is it present in tail? No. This statement is correct now. So I have to consider this element as a result. So C plus A plus merge off. After selecting this one in the result, what I have to do? Remove that element from all the lists. So I have to remove this one. O, it is not there. Okay. Next, here from here I have to remove. Completed. Next step is what? This I have to check for this one. That is what? O. This is head element now. Is O is not present in any of the tail part? Let us check. It is present in the tail part. So I should not consider this one. I should not consider as a result. So I have to go to next list. So here, so why I'm going to next list? In this list, it is not found. So that I'm going to next list. As there is one element, I'm not going to next list. As it is not found, I'm going to next list. So when we go to next example, you'll get a clarity on this point. Now I want to check for this B. Now head element is what? B. So is B is whether it is present in any of the tile list or not, let us check. Tile part or not. So it is present here. Is it a tile? No, there is only one element. If it is one element, it will be considered as head only. Okay, right. Now here what I have to consider? Here I have to consider C plus A plus B. I have to consider in the result. Okay, plus merge of B. I have to remove 0 comma 0. Sorry, not 0. O comma O has to be here. Now there is only one O. So is it head part or not? It is a head part. Is it in any tail part or not? Not there. So this has also be considered. So CAB object is the answer. So now observe here. What is the answer of this one? CABO object. In this way, we got the result. Okay. So now don't worry, we will go in depth about this one. So before going to see the examples, we have to understand these points. Once again, I'm repeating. If head element of first list is not present in the tail part, if head element of the first list is not present in the tail part of any other list, then we will consider that element in the result. If it is present, already we have seen, if it is present, object is present, what we have to go to next list. Okay. If it is not present, I will take it as a result in the result and I will remove that element. Now observe, this is about a small example. Now I will take somewhat big example so that you will get clarity on that particular concept. Just I will leave this one, delete this one. Just I want to keep that part aside. So now what I'm going to consider, I want to consider another example. That is, let's take, so as first one is object, just I will let OB. This is a class name, object class. Here I will take 3 class A, B, C. Okay. After that, I will execute the same program in our program also. Same concept I will explain in our program also. So just I will take it in D. Okay. After that, I will take it in E. Right. Now here I will take it as F. That means what? The meaning of this one is what? The superclass of A is object, B is object, C is object. For D, A is superclass, B is superclass. For E, B is superclass, C is superclass. For F, D is superclass, E is superclass. So first I have to find what? First I have to find the linearization of A. That otherwise I can say MRO of A. So for this diagram, first I will write a code and I will show you what is the result so that whether we are getting that result or not, we can understand clearly. So just I will write a code for this one. How can I write? First ABC are there. So ABC are already here. So just I will remove this one. Just ABC classes are there. Okay. Just I will write a pass here. Pass statements I will write. Next after that DEF are there. So 3 more classes I will take. DEF. Okay. Here I will take D, E and F. Now, what is the superclass of D? A and B. D, what is that? A and B. A comma B. Next, after that E, for E, what are the superclasses? Sorry. What are the superclasses for E? B and C. B and C. Next, what are the superclasses of this F? D and E. What are those? D and E. Right. Now, just I want to check for all these cases. So now, one by one, I will ask you so that you will get a clarity on this one. So what is the MRO of A? First, I will write MRO of A. That means what? Linearization of A. It will give you what? A. First, you take A. There is only one superclass. So you'll get what? Object. Next, for B, MRO of B, I will check. It will give you what? First same class and its super class, that is what? Object. So as we here there is only one level, it is very easy to understand. So MRO of C, what we are going to get? C object. There is no problem up to here. Next, come to this D. MRO of D. So what I am writing? First I am writing A according to the order left to right. So see here what I have written, A comma B. So that first it will give you D. D. After that we will get what? A. After that we will get B. After that we are going to get object. I can say this one, no problem. Next, MRO of E. E let us take. So as here E will be taken. Next after that I have written what? According to the left to right, B. So here also I will consider B. Next I will consider C. Next automatically object will be there. Up to here there will be no problem. Okay. Up to here I will show you the results. So first I will write A dot MRO. A dot MRO. So A dot MRO gives you what? A and object. So what we got? A and object. For B and C also, B object and C object will be returned. So for B, see what we got? B and object. Next I will write for C. We will get what? C and object. C and object. Now I want to write for D. So just I will save and observe now. So DAB object. Again telling DAB object. Let us see output. DAB object. Yes, we got it. There is no problem. Next, I will go for E. Okay. Now observe what we got. EBC object. EBC object. Yes, completed. Up to here, no problem. Now observe clearly. Now I want to go for F. So before going to that, I will show you the according to our estimation. I will write here according to F. So as F is here, so first I have to write F. So as superclass of this one is what? D. So I will take D. Next, should I go to here or here or here? I may not know. So first I will go to here. After that I will go to A. After that I will go to B. After that I will go to C. After that I will go to object. Let us see whether this order is correct or not. We think in this way, but actually it is wrong. But let us check. See, I am going to write F dot MRO. So it's giving me what? FDAB, FDAE. See here, FDAE. I got what? FDEA. Okay, after that BC he got. I got also BC. There is no problem. That means what? Some mistake is there here. So how it has to be rectified and how it has to be where it has to be checked. So I think up to here it is correct. It is correct. It is correct. It is correct. It is and it is also correct. But here it leads to wrong because I cannot say directly. Okay, but as it is a small diagram, I can say. But if it is a somewhat large diagram, I will take one more large diagram after completing these examples, small examples. Then you will get a clear clarity about this concept. Right. Anyway, now I want to do about what? MRO of F. So just I will, as it is wrong, I am going to remove here. So all remaining are correct only. So now I'm going to consider MRO of F. MRO of F. Listen carefully. What is the formula we are having? MRO of F is nothing but L of F. We can consider L of F also. There is no problem. What we have to take? F plus we have to write what? Merge of. Merge of. I am taking MRO also. I can take MRO of. What are the things we can have to write here? What is the superclass of this one? D and E. So D, comma MRO of E, comma we can write what? DE. Okay. In this way, we have to write first. As we have seen the formulas, you know how I have written this statement here. Okay. After this, what I have to do? After this, what I have to do? I have to consider according to the formula, is it correct or not? Yes, it is correct only. So now I have to consider about F. So here, just I want to find what MRO of D and MRO of E. Already these are present here. First, I will write them. Merge of MRO of D is what? DABO. I will write O. DABO. Next, MRO of E is what? MRO of E. That is what? EBCO. EBCO. Next is what? DE is there. Yes. This is my statement after this one expression. After this, what I have to do? Right. Now see. This is what head. First, I have to consider this head D. Now I have to check whether it is present in any of the tail or not. Now come to this list. Is there any D? First, D is not there, so no need of checking. Is there any D or not? Yes, D is there. Is it not present in tail? Yes, it is not present in tail part. So I have to consider this D in result. So F plus D I am going to take plus merge of, just I have to remove this one. Remaining elements I have to write. AB0, EB, C0, C1, O it is object. Okay. Next only E. Okay. After this, what I have to consider? Now, next statement, F plus D plus. Again, head is what here? A. So, is A is present anywhere? We have to check clearly. Is A is present? It is not present here. So, what I have to take? 1 minute. Let us check clearly. 1 minute. Here, EBC, okay. DAB. DAB not, okay. So here what I have to take? Here I have to consider this A. Is A is present anywhere? Not there. As head is there, it is not present here. It is not present here. So no problem. It is not present any tail part. So I have to consider A. So if you see the output here, FDA, we got it. So okay, finally I will check plus merge of B object comma EBC object comma E. Okay, right. Now next one is what? F plus D plus A plus. Now I have to check for what? Head B. I want to check for B. Is B is present in any of the tail part? Yes, it is present in the tail part only. So I should not consider this one. I should not consider this one. So if I am not going to consider this one, I have to go to next list. I should not check about O. I have to go to next list. So I have to consider this one, E. So E is head now. So now here E is there. So I have to go to next list. Is E is there in any tail list? No, it is in head part only. So now I have to consider E here. So E I have to consider next. Merge of what are the remaining things? M object. E has to be removed. So B, C object are remaining. Okay. Next. Now I have to consider again. I have to come back to this list only. First list only. Now I have to consider what head element B. I have to check in another list. There is only one list. So I have to check here. So is there any B in tail list? No, it is a head list only. There is no problem. So I have to take what? F plus D plus A plus E plus B plus merge of, I have to remove B. Only what are there? 0, CO are there. CO is nothing but object. Now see. So here O is there. It is a tail part here. So I should not consider this O. So I have to consider what? C is head part. Is there any another list is there to check for C? Not there. So C has to be considered. Then what happens? F plus D plus A, E, B and C. Now what? Merge of object comma object. Object comma object both are head only. So finally what I am going to get? F, D, A, E, B, C object. This should be the answer. Now let us check whether we got it or not. Okay, see here FDA, FDA, yes, FDA. Next EBC, EBC, yes, last one is object. Okay, EBC object. Okay, in this way we have to understand how the method resolution is going to take place in our Python. Just by seeing this order I cannot say. Okay, as it is a small diagram, I am having one more small technique to understand this one, but I will not discuss this the technique because it will work only for the shorter length of inheritances. If I take a 20 classes and if I keep in different levels of inheritances for that, it is very difficult to search by using that technique. But by using this technique, it is very easy to understand. So in this way, method resolution is going to take place. Don't worry, I will take two more examples for this one so that you will get a clarity on this one. Okay, yes. So this is about one example of your MRO, right? Now these 2 points are very important. I think you have understood about these 2 points now. This is what remove will be there here. Remove from. Okay, right. Now, next example I will take. One more example I will take here. So some object class. First will be what? Object class will be there. OB I will take. Okay. So from this object class, I will take A, next some B, and next some C. Next I will take some D here. You can get any type of logic, any type of diagram, so that we can get more clarity. Just I will keep here some B, E, C, and also A I will take. You can keep any type, no problem. You can draw any type of diagram or any type of inheritances just by using this logic. I can do it. So by seeing this, just I will write a classes. So first, which classes are there? A, B, C classes are there. Next, for D class, what are the super classes? Only B is there. Okay, I have taken only B. Oh, let us take A also. Okay, so for D we are having what? A comma B. After that, for E, what we are having? For E, A I have written, and C for E. Okay. Next for F, I will take. This is F. So for F, what is super classes? D and E. Okay. This is the class I will write. This class I will write. Otherwise, first let us solve this one, and let us go back to our programming. So first, what we have to find? Find MRO of A. Otherwise, L of A I will take. No problem. Anyone we can take. L of A and object. So just I will write AO. Okay, next L of B. B is what? B and O. Nothing but object. Next for L of C. It is nothing but what? C and object. CO I will write. Now let us see this one. Now what we have seen? L of C. Now L of D, let us see. L of D is what? L of D is, first I have to write D, and after that we have to see what? A, B, O. I have to write what? A, B, O. Next I am going to write L of E. First thing what? We have to write E here. Next for E what? A and C. A, C, object. Now we have to find for what? L of F. How we have to find? F plus merge of, okay, merge of what? Merge of, we have to write, what is the superclass of this F? D and E. So we have to write D, L of D or M of D we can write here, comma, L of E, comma, D and E here we have to write. Right. Let us write what is meant by L of D. What is L of D here? DABO. DABO, comma, L of E is what? EACO. Finally, we got DE here. So first, what we have to check here? Merge of, it is a root here. Is it any tail part? Sorry, it is a head here, not root. It is a head. Is it present in any of the tail parts? Let us check. It is D is not present. No need of checking. Here it is present, but it is a head part only. So no problem. I have to consider it in a output. That means what? 1 minute. Here I will write. Okay. This has to be considered in a result. So merge of, I have to remove that one. So what I have to do? A, B object, next EA, C object, E, because I have to remove that one. Next, F plus, D plus, merge of, right. Now what? This is the head part. Is it present in any of the tail parts? Let us check. Yes, it is present in tail part here. So I should not consider A now. I have to go to next list. I should not come here. I have to go to next list. That means I have to come here now. Now check E here. This is the head part now. Is it present in any of the tail parts? Let us check. It will come here. It is not present in a tail parts, as there is only one element. It is a head element only. So now I will keep it in a result and I will remove in our lists. Merge of A, B, object, E, A, sorry, E has to be removed. Sorry, E has to be removed. I have removed that. So ACO object completed. Now what we have to do here? F plus D plus E. Now about A we have to talk because it is a head now. So it is head. Is there A present in any of the tile lists? Not there. So I have to consider it in a result. Plus merge of B object, C object I have to take. Now what is the head element we have? We have head element as B. So is B present in any of the tile lists? Not there. So I have to consider B. If I remove B, C will be there. Next, if I remove only O, object will be there. So this is the order finally. F, D, E, A, B, C, O. Okay. Let us check now whether it is correct or not. I have written that program. So here I have changed it. Right. Now observe here. I will execute the program now. So what is the output we got? F, D, E. First I will check F, D, E. F, D, E. After that A, B, C object. So what we got? A, B, C object. So it is correct. So till now we have seen two examples. Now I will take somewhat big example so that we'll get a clarity. I will stop the concept of this C3 algorithm because internally what is going to be done, how the method resolution is going to be take place, we have to understand. One more example I will consider. Okay. Just I will clear entire thing because already now you are familiar with these points. Right. Now the diagram will be somewhat bigger. So listen carefully. Here I am going to take object class. Okay. For this I am going to take A class, so B class, C class, D class, and also I will take some E class. So this for next level, right? F, G, H I will take. So I will make these two as, for this H I am going to make D and E as a super classes. And for this G I am going to make D and B. And for this F I am going to make C and A. We can draw it anyway, no problem. Just I will keep this one also. So I want to make the thing as a complex now because already we know simple things. I want to make complex things. So I, H and G. So now for this one, I want to find the concept of method resolution. For I want to find how the method resolution will be take care. Now, just I will write what? Just I will write here LROs of A and remaining all these things. Sorry, MRO of all these classes. So linearization of A equal to what? Directly I'm writing, already we know that AO. Linearization of B, what is that? BO. Linearization of C is what? CO. C object. CO is nothing but object. Next, D is what? D object. E is what? E object. Next, now from here, let us check clearly because it is easy, but I have to check slowly. For F is what? A, B, C I will take. So first I have to write F, A, B, C. Next one, for G I have to consider. So if you want to perform stepwise also we can perform, but as it is in one level only, I'm going to take directly. So F, A, B, C, O here, I have to write O also. Next, for G, what is there? B is there, D is there. B is there, D, sorry, G I have to write G, B, D and object. Okay, for G only two, right? Next, for H, L of H I am going to take. For H, how many are there? D, E is there. So first I have to write H, D, E, O. So up to here there is no problem because as these are only in one level. Now I want to take about I, linearization of I, or I can consider M or O of I, linearization of I. What I have to take? First I have to take class I plus merge of L of linearization of or MRO of, what is the superclasses of I? F, G, H. So F, next one is G, next one is H. Okay, so I have to write all these classes here, F, G, H. Okay, now let us write what is meant by L of F. Already we know L of f is nothing but what? FABCO. FABCO. After that, we have to consider what? G. GBDO. GBDO. After that, we have HDEO. HDEO. Finally, we have what? FGH. Okay. Now let us perform the method resolution or C3 algorithm on this one. So first I have to consider I. After that, F is a root. F is a root. Sorry, F is a head. Is this head element is present in any of the tail parts in any other lists? F is not present in the list. F is not present in this list. F is present in this list, but not in tail. So that F can be considered in the result. So F plus merge of, I have to remove from the lists. So ABC object, GBD object, HDE object, GH. Okay. After that, I plus F plus, here root is what now? A. Sorry, head is what? A. Is A is present here? Not there. Is A is present? Not there. Is A is present? Not there. So A will be considered in the result. So and we have to remove that one in the lists. So BC object, GBD object, HDE object, and GH. Right, next. SA plus. So here what I have to consider? B is in head now. So is B is present in this list? Yes, it is present, but it is in tail part. So we have to leave this particular list and I have to come here because I have to check head elements only. So I have to leave this one. If I go to C, what happens here? If I go to C, C will be tail part. So I should not check for tail parts. I should only check for head parts. So as it is not there, I have to go to next list and I have to check for what? G. Yes, so G is present it here? No, not present. Is it present here? Yes. Is it present in tail part or head part? Head part only. So I have to consider this one my result. G plus merge of, I have to remove G from the list. So BDO, HDEO, next H. Okay. Next one. What is the head element? B. Head element is what? B now. So is B is present here? Yes, it is present, but not in tail part. So no problem. Is it present? Not there. Is it here? It is present? Not there. So what I have to take here? B in my result. So and I have to remove that one from the lists. So here CO, here DO, here HDEO, and here H. Right. Next. I, F, A, G, B. Now remaining are what? Sorry. Remaining are what? Right. C is head now. C is head. Is C is present in any list? Not there. So no problem. I will take in my result. So merge of object comma D object comma. Next what I have to take? HD E naught and H. If I consider here, okay, anyway, I will write here first. I F A G B C. Next I have to consider what? First O I have to consider. Is O is present in any of the lists? Yes, it is present here, but in a tail part. So I should not consider this one. I have to come to next list. D is there. So D I have to check. Is D is present in any other list? Yes, it is present in the list. Is it in head part or tail part? Tail part. So I should not consider this one. Again, I have to come to this list, third list. H. H is what now? Head element. So now I have to check whether it is present in any list or not. Is it present in any list? Yes, it is present here. So is it in tail part or head part? Head part only. So I have to consider this one in my result. So H I have to take. So and I have to remove that H from the list. So DO, DEO, and H has to be removed. So up to here only. Next, what happens? I plus F A G B C H. Now see. Here object is a head element and it is a tail element here. So I should not consider this object. Now come here D. So here D is head element and it is not in the tail part of this one. So I have to consider D in my result. Next and remove in the lists. So what will be there? Object, object, EVO. Okay, next, last one. Here what I have to consider? I, F, A, G, B, C, H, D. Next, what I have to do? Object. So it is in head part only, but here it is in tail part. So I should not consider object. Next, come to E. E is in head part. It is not present in any other list. So I have to consider E. Now only objects are remaining. So last I have to consider object. So what is the order? IFA, GBC, HDE, object. So whether it is correct or not, just let us take a small scenario of this one. So just what I have to take? 5 classes. First I have to take A, B, C, D, E. So to make you clear, I will take A, B, C, D, E. I'm not going to take any methods because just we have to understand how the resolution takes place. Okay. A, B, C, D, E. I will take here E. Right. After that, F, G, H are there. Okay. Here I will take this one as F, G, and H. Okay. For F, what are the superclasses? A, B, C. For S, we are having A, B, C. And for G, what we are having? B and D. B and D. B comma D. Next one we are having what? H we are having here. For H we are having D and E. D and E already it is present here. Next, for I am going to take. For I, what we are having? F, G, H are superclasses. F, G, H. Okay. Right. Now let us check from F onwards. F dot MRO I will check. Already we have written that F dot MRO means what? F A B C object. F A B C object. We got it. So it is correct. There is no problem for this one. This is correct. Right. L of G I want to check. That is nothing but MRO of G dot MRO I want to check. So what is the output? GBDO. GBDO. Yes, it is correct. Next H I want to check. For H, what is that? HDE object. HDE object. Yes, it is correct. Now finally I want to check for I. Okay. Now observe what is the answer. So see what? Just I will show you I, F, A, G, IF, AG. So see I, F, A, G. Okay. Next B, C, H, D. B, C, H, D. B, C, H, D. And finally we got what? E and object. So here also we got E and object. So in this way, internally the method resolution will be take care. But as this is not important for the curriculum, that means what? As for the subject, as if you are studying in BTech, it is not such important. No one will discuss about this one. But when we are going to learn the subject in depth, then we have to understand about this concept. Generally, this concept will not be discussed in anywhere. Okay. Only few of the faculty members will teach this one. So better if you know this one in detail. So in this way, in our Python, method resolution will be take care. So just once briefly, I will tell you what we have to consider regarding to this method resolution order. So our Python is going to follow C3 algorithm for this method resolution order. Okay, it is an algorithm. C3 is an algorithm. So generally in this order, in this method resolution, first we are going to give priority to whom? First priority will be given to child. So if child does not contain that particular method, we will go to parent. If multiple parents are available, then where we have to go? From left to right, we are going to consider. If it is one level, it is no problem. But if you are going to multiple levels of inheritance, then we have to follow the algorithm called as C3. So or we can consider it as the C3 linearization algorithm, or some places we can consider it as a linearization algorithm also. But generally it is called as linearization algorithm only, but official name is C3 linearization algorithm, or we can consider it as a C3 algorithm also. So this is about how the method resolution takes place in our Python. So in next session, last concept of our inheritance will be discussed, that is super function. So it is very important, and with that we will end the concept of inheritances. Thank you.